Hey folks, Prof Psych here. Good to see you. Going to do a specific video on the sign test, okay? Not that sort of sign. These signs, believe it or not, just simple plus and minuses. We'll get to it in a minute. Now, key question. Why do we use the sign test? Let's remind you of some of my previous videos, okay? First question is, well, why use a statistical test anyway? A statistical test allows us to say with a level of confidence that a result is significant, okay? We're not just looking at it and saying, yeah, that looks good. It means we run it through a statistical test and we're saying now with confidence that this result is significant. If you go back to one of my prior videos, you'll remember the grid that tells us which statistical test to use. So essentially we use the sign test when we got nominal data, repeated measures or matched pairs, and when we're looking for a difference, not a correlation. Go back to those previous videos to remember that grid. Okay, now let's take an example that we'll work through with the sign test to explain it. Just imagine this is my hypothesis. Participants will score higher in a psychology exam when they watch Prof Psych's sign test video than when they don't watch the video. Okay, we got a hypothesis, all right? Now, there are a number of stages to the sign test, and these look quite complex, so I'm going to explain each step by step for you, okay? Now, the first thing is what we do is we've got some data here. You'll see that I've got a number of participants, so I'm using my example, okay? Students who watch Prof Psych video, blah, 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 okay? And I've got my 18 participants here, and there's the experimental condition when they did their exam, their test after watching the video, and here's the control condition when they did the test without watching the video, okay? And we've got some presumably test results here, okay? Step one then is very simple. We have to subtract the participant result in the experimental condition from the control condition, okay? And we give it a sign and then we just record that sign in a column. So we take away the experimental from the control. So 19 minus 23 gives us minus 4. We forget the 4, the number's not important, but we keep the sign. So next to that participant, I just record a minus sign, okay? I continue doing that for all my participants, so I keep subtracting the experimental from the control, and if it's a minus number, I put a minus sign. If it's a plus number, a plus. Now, if we get any that are the same, so we can see here participant 13 scored 19 in the experimental condition, 19 in the control, 19 minus 19 is 0. We just record a 0 in that right-hand column. So I've got plus signs, minus signs, and zeros. Here's what we do with them, okay? I now add them up. So if I go back to that data, okay, I add up how many minuses I've got, how many pluses I've got, and how many zeros. And it looks like this. I have 6 pluses. I have 9 minuses. And although I have 3 zeros, the zeros are showing no difference, no change, so they actually get crossed out. They become irrelevant moving forward, okay? So, second step is to get what we call the S value. S value is simply the least frequent sign. Well, I had 6 plus signs, I had 9 minus signs. The least frequent of those is the pluses. There are less of them. There were 6. So my S value becomes 6. So I've now got my S value. Now I've got to, step 3, get the N value. N value is simple. That is calculated by adding up all the pluses and all the minuses. Well, 6 plus 9 is 15. My n value is now 15. So I've got an s value, I've got an m value. This is going well, okay? Next step is I have to decide if the hypothesis is a one-tailed or two-tailed hypothesis, okay? Is it directional or non-directional, to use other language? Okay, and I'll need that in a minute. So let's look back at the hypothesis that we were using, okay? Participants will score higher in a psychology exam when they were, right. The word higher makes it one-tailed, directional. I'm suggesting a direction for this particular hypothesis, okay? That's our example. Now, step 5. I've got my S value, I've got my N value, and I now need to compare those to a table of critical values. That table is published. We don't have to invent it. We compare to it, okay? Now, we're going to look, the simple rules here, nearly always in psychology, is that we're going to look in the 0.05 column. Remember one of my previous videos explaining this, explaining why we look at that for the probability level, okay? So we're going to look in the 0.05 column, okay, and put our M value in there, but the tables will publish for both one-tailed or two-tailed. So we have to make sure we look at the correct column. We'll see this in a minute. Now, when we look down our N value, which we'll do in a second, okay, we will look across to the 0.05 and we will find a number in the published table. For our result to be significant, our S value that we had must be equal to or less than the critical value in the column that we found for it to be significant. Let's do this now. We know the steps, we know the rules. Let's do it, okay? So, we've got our S value, we know it's 6. We've got our N value, we know it's 15, okay? We know we've got a one-tailed hypothesis. Here's our S value, okay? Now, so, I'm going to move over. Here we have 0.05 for a one-tailed test. So I'm looking down this first column. My N value was 15, so I go all the way down to 15. I go across to the first column, and the published value in the table, the critical value is 3. Okay, critical value 3. Therefore, our result is not equal to or less than the critical value. In fact, 6 is more than. So the result is not statistically significant, and I have to reject the experimental hypothesis. In other words, the experimental hypothesis that participants will score higher when watching Prof. Psych sign test video is not true. It is not a significant finding. What the heck are you watching the video for then? That's a joke. Okay, folks, go back through that, re-watch it, okay? So step by step, the maths is easy, it's about practice, okay? Can you do my example just looking at the raw data on your own? All right, folks, keep watching Prof. Psych. Don't forget to subscribe on YouTube, and you can follow on Instagram. Keep up the hard work, guys.